All right, and we're moving forward. And the good thing about our last three lessons of this unit is that we're going to really keep using the same information again and again and again. And what's changing is how that information is represented. Is it a linear problem? Is it a linear system problem? Is it next lesson, a quadratic problem? All right, and then how do we solve those based on those particular things? So this lesson, all right, is going to focus on linear systems. The prior lesson just focused on linear equations. So you can see standard 8.3 here, I can use my knowledge of angles and relationships to solve problems using systems of equations. All right, and this is on page 130, all right, in your workbook. And once again, I'll just let you pause the video real quick, and we'll go through and circle what you think is a system of linear equations. All right, so, a system means more than one linear equation. So that would be this one. Notice this doesn't have more than one, so it's not a system. This has more than one. This isn't linear, all right, so that can't work. This isn't more than one, and then we have 3 here, so that's a bigger system, all right. Technically, we typically want just two equations, but if you have 3, sometimes we can make things work with that, but definitely have to have 2. All right, so now what we're going to do, once again, is just review solving linear systems. So now, the way you know it's a linear system problem is that you will have 2 variables, right, in your diagram. So you will see an x, right, and a y variable in your representations here. Now, anytime we have an x and a y, that means we need 2 different and distinct equations, okay? So that means you have to find 2, all right, different angle relationships from your diagram. All right, so we want to find 2 specific relationships, all right, and use those to develop our angle relationships, okay? All right, so now, here's what we want to do. We want to find the value of x and y. So now, once again, we can see that, I have an x in this expression, I have an x and a y in this expression, an x and y in this expression, and a y in this one as well. Now, if they're all one variable, if everything just had x's, or if everything just had y's, it would just really be a linear relationship. But anytime we see that mix of x and y's, that means we need to set up 2 separate relationships. So now, what I want to do is have you just kind of pause the video and think about 2 relationships that you see in this picture, and then how we could use those relationships to set up 2 equations. So go ahead and pause the video and see what you can come up with. All right. So now, what I see when I look at this is I see we have a pair of vertical angles, correct? All right. So we have 2 angles that are vertical, right? And we know if we have vertical angles, that implies that measure of angle 1 is equal to the measure of angle 2, right? Whatever 2 angles we have, right? The second relationship that I saw is that we have a linear pair down here, right? Okay. And that means that the measure of those 2 angles has to equal to 180 degrees. All right, so that's what we're talking about when we say 2 different angle relationships. So we have one up here, we have one here to relate x and y. So now we have to, using those relationships, we're going to create those 2 equations. So if I take my first one here, that would be 8x plus 1 equals 3x plus 2y. And if I take my second relationship here, negative 5x plus 20y plus 5y minus 5 has to equal to 180. All right, now here's the other thing is that when we think about systems of equations, we really want to organize our equations to look a specific way, all right, so that we can solve. And typically we're going to use elimination more than substitution. And so I'm going to kind of put up here is that this is typically what we want our equations to look like so that we can align everything and we can use the elimination method to solve. So notice here, all right, I have an x and a y and a number, and so I need to get this x over here with this x. So I'm going to subtract 8x from both sides. That's 0, and I get 1 equals negative 5x plus 2y. And then remember, we can just flip this, all right, negative 5x plus 2y equals to 1, just like so. All right, now notice over here we have some like terms that we can work with here. So notice I have 2 y terms, so negative 5x, and then this would be plus 25y minus 5 equals 180 degrees. And then notice now I have my x and my y on the left side. Now I want to move this number to be on the right side. So I can add 5 and add 5 here. So I get negative 5x plus 25y equals 185. All right, now, the reason we do this is because we want to, all right, once we have our two equations written, we want to eliminate either the x's or the y's, all right, and it doesn't matter which ones, you'll get the same answer eventually, all right, but then we want to make them opposite coefficients if they're not. So that means we either have to multiply one or both equations by a number to be opposite. So we want 4 and negative 4, 10 and negative 10, 17 and negative 17, so that when we add them together, all right, we get 0. So I'm going to start with the x's because I see I have a negative 5x here and a negative 5x. So those are almost opposites. I really just need one of them to be a positive, all right, 5x, and then it would become, all right, opposites. So what I'm going to do is I'm going to keep the first equation, negative 5x plus 2y equals to 1, and I'm going to multiply this equation by negative 1. And notice when I do that, that becomes a positive 5x. When I multiply that by negative 1, it becomes a negative 25y. And then when I multiply that by negative 1, it becomes negative 185. And then we can now add those together. And notice that is 0. And then I get 2y minus 25y, and that's negative 23y equals negative 184. All right, now what we want to do is divide both sides by negative 23. All right, let me do that on my calculator here. 184 and 23 gives us 8. So y would equal to positive 8. Now, there's a couple different ways, all right, to get x. So one is, once I know what y is, I can go back to either equation. It does not matter which. You'll get the same x value in the end. All right, and I can go back and plug y in and solve for x. I'm going to just do that on this equation right here. And notice that we get negative 5x plus 16 is equal to 1. And then once again, now it becomes, all right, one of those linear problems that you're very, very familiar with. And I can divide by negative 5 here, and I get x equals 3. All right, so there are my values for y, and there are my values for x. Now, once again, if you go back and plug these in, all right, and test those initial relationships, hopefully they give us something that is true. So I'm just going to do that on our first relationship here to show you, right? Okay, so it's 8 times 3 plus 1 is 25. And so now if I do the right side, okay, 3 times 3 plus 8, all right, 2 times 8, there we go, equals 25 as well. So I can say I get 25 equals 25. All right. And so once again, using those values to go back and plug them in, all right, is really, really good practice, all right, to see if you are correct. All right. So that's really the idea here. So when you look at the rest of your work, all right, if you look at page 131, all right, you've got one problem, two problems, and then a third problem here on page 132. All right, so once again, the other thing is that for some of these problems, there might be more than one correct equation or set of equations to use. All right, so when you're solving, your equations may not match the answer keys precisely, and that's okay. All right, because we can't work all the different combinations out there, but what should be the same in the end is your value for x and your y. So as long as that happens at the end when you check your work, that is really, really good. All right, so that's all for this video. All right, go ahead and finish those next 3 problems, check your work, and let me know if you have any questions.